Hi everyone, I'm Sunil, and in this presentation I will demonstrate natural testing of smart homes by executing home automation events generated by Helion on Home Assistant platform. Helion is a framework that predicts realistic scenarios containing home automation events. For this, Helion uses user-driven routines, which are trigger action programs that execute an action such as turning the camera off in response to triggers such as user coming home. So how do we get to these realistic scenarios? First, we need to get some idea of the order in which these routines execute. Hence, we take clues from the users, which we call execution indicators. Now, we need to create home automation sequences using user-driven routines and execution indicators. We use the process called informed scheduling, which places these routines in a time series that approximates how the user wants these routines to execute. Then we model these sequences using n-gram language modeling technique, which subsequently allows prediction. After that, the model is used to generate realistic scenarios. These scenarios generated by Helion can be used by different stakeholders to evaluate security, safety, and privacy of smart home systems. In the demo, I will present the execution of these home automation scenarios on Home Assistant platform, which is a popular platform that allows integration of different smart home devices and services. This is the default page that we can see after running the Home Assistant server integrated with Helion. The goal here is to execute scenarios of events predicted by Helion on the Home Assistant platform. While we will be mostly working with Helion, as you can see in the navigation drawer, we keep the default features provided by Home Assistant as is. Now I will demonstrate how we can run Helion on Home Assistant. For this, we need to configure the parameters that is used by Helion for prediction. We have two main configurations. First, we can choose the order of n-gram language model. This basically allows us to set the history of events used by model to predict next event. Second, we can also choose the flavor of the model. The up flavor allows us to obtain events that are highly likely to occur in the home, whereas the down flavor allows us to obtain events that are least likely to occur given the history of events. The rationale behind using down flavor is to obtain scenarios where the devices might be misbehaving or if there is a deliberate misuse. Next, we provide a series of events as input, which is represented as Helion tokens. As you can see, I have entered 3 events as input. The time is night, the motion is detected, and the door is locked. Now we can run Helion to get a set of predictions. And we can keep on predicting new events after that. We can also change the flavor of the model. And we can restart the prediction by pressing Run Helion again. Finally, we can reset the prediction and give it a completely new set of input. Thank you for watching our demo. You can find other details on the code in the GitHub repo.